Hello everyone. Welcome to the 12th video of Azure AI Fundamentals Certification course. In the previous video, we discussed about machine learning and various types of machine learning. In this video, we'll see a demo in Azure Machine Learning Studio. The idea for this lesson is inspired from the AI-102 course I attended to pass the certification. I'll provide the link to the course in the description box below. Without further ado, let's get into the video. Data is a very important part of machine learning. It's on our data we build our machine learning model. This dataset can be divided into three. One is the training dataset, and this data is used to train our machine learning model, and it comprises of 60 to 80% of our data. And then there is validation dataset. The validation dataset is used to tune the model's hyperparameters and to provide unbiased evaluation of the model's performance during the training process. It can be considered as an intermediate testing ground. We can provide 10 to 20% of our data as a validation data. So validation dataset is different from test dataset. Test dataset is used to test a fully trained model. But in the case of a validation dataset, it is used during the training of the model. So we can use this dataset and can adjust the parameters of the model. It is an intermediate testing ground. Then finally, there is a test dataset, which is used for the final evaluation of a fully trained model. And why do we use test dataset? Why don't we deploy our model after training it? It is because we need to be sure our model is doing a good job. So we test the model with the test dataset with unseen data and will evaluate how the model performs. And only if we are satisfied with the model, we need to deploy it in the real world. So we can use again 10 to 20% of the dataset as test dataset. The validation dataset is not necessary. We can skip that step, but it is better to have a validation dataset. Now, what is model overfitting? It is a term used when a model performs very well on the trained data, but it performs poorly on unseen data. So we know that a machine learning model will try to learn the correlations between data. That is how a machine learning model is trained. But what if the machine learning model just learned the training data by heart? It's not able to figure out any relation between those data. It just by hearts the data, and later on when an unseen scenario is given, it is not able to predict or do what it is supposed to do. That is known as overfitting. So to avoid overfitting, we use these training, validation and test dataset. Now we know about data splitting in machine learning. Next, what we are going to do is to see a demo in Azure Machine Learning Studio. For that, let us go to the Azure portal. This is my Azure portal, and here I'll select Azure Machine Learning. I have no workspaces currently. We'll create one. I'll create a new workspace, and I have an already existing resource group. I'll select that. I'll provide a name. I'll go with the default region. One thing to note is that when we create an Azure Machine Learning workspace, the storage account and key vault along with application insights is deployed default. So this comes along with our machine learning workspace. Again, I'll go with the default here. All others, I'll go with the default. Finally, I'll review it and create the resource. It will take a couple of minutes. I'll resume the video and come back after it is deployed. Now the deployment is successful. We'll go to the resource, and here this is my machine learning workspace. And from here, we can launch Azure Machine Learning Studio by clicking this icon. So this is the Azure Machine Learning Studio. It is similar to Azure AI Foundry, but it is meant for machine learning models. So here on the left side, you can see all the features in the Machine Learning Studio. There are notebooks, automated machine learning, designer, then data, jobs, pipeline, environment, models and all. So in our demo, we'll be seeing Azure Machine Learning Designer. But before that, we have to deploy a compute resource. So that is where all our training is being done. First, we'll deploy a compute instance. So here you can deploy either instance or you can deploy cluster, Kubernetes cluster, attached computes or serverless instance. So now here we are going with compute instance. I'll click on new. I have given a name to the compute instance. Then you can select CPU or GPU. We are not doing a deep learning model. We are going with a simple model. So I'll select CPU. We don't need GPU. GPU is for very high workloads. Then you can select any of this instance and this will incur cost for you. I'll go with the second one with 4 cores, 14 GB RAM and 28 GB storage, and I'll review and create the instance. Everything else I'll go with default, and here I'll create my compute. So it's in the creating stage. So while it's being created, we can go to this Designer Studio. So this is how it looks like. We need to create a new pipeline. So there is pre-built model as well as custom ones. For custom one, you have to create the modules, but here we are going with the pre-built one, and we will create a new pipeline using pre-built components. So I'll click on this plus sign, and this will take you to a blank canvas where you can create a pipeline and visually view it. You can drag and drop the modules you want and create the pipeline as you wish. So another thing is you can upload your own data, but here I'm going with the sample data provided by Azure. There are 16 types of sample data, and here we'll go with automobile price data. I've seen that in the regression model. When we provide features, the model will be able to predict the price of that particular automobile. So that is what this data is about. Now I can click use this data, or I can drag and drop this data to the canvas, and I can view data here. So this is the data. There are 205 rows and 26 columns present in the data. So here you can see each of the features, symboling, losses, fuel type. There are so many features present here. And here in the last column, there is price. So you have to select which all features you need and what is the label or the output you are expecting. So you can select price, city, peak RPM, etc. as the feature, and we can predict the horsepower. But in our case, what we are going to do is we'll select others as features and we'll select price as the label. That is what our model want to predict. We need to predict the price of the automobile. And again, you can see there are 26 columns. We don't need these many columns. We'll keep our data simple. We'll select only features that are highly related to our label, which is price. For that, here we can search for filter and we can select this module. It will identify the feature in a dataset with the greatest predictive power. I'll drag and drop that one here, and I'll connect my data to filter based feature selection. So here you can see a caution warning. I'll click on that. So here you can see what it is. Now you can here select number of desired features. So there are like 26 columns in our data, and I want to keep the data simple. So I'm telling to select only 5 features, and the model will select those 5 features. And there is a feature scoring method. So what it does is it will select the feature which is highly correlated to the output or the label. So there are 2 types. I'll go with Pearson correlation. All the other features it will eliminate. Then what is the target column? What we need to predict? That is price. So I'm selecting price as the target column or the label, and I'll configure and submit. I'll create a new one. I don't have any existing experiments, so I'll click create new. I'll provide a name for the experiment, predict automobile price, and then I'll review and submit. Now I'll configure and submit this job. Oh, I haven't selected the compute cluster. I have to select my compute instance. It should be already deployed by now. And yeah, it's deployed and it's running. I'll select that instance. Then I'll review and submit the job. So this particular job, filter based feature selection, is going to run in our compute instance, and let us submit the job. Now it's running in the background, and here you can see our job is running. Now let us wait for a few seconds. If you click on view details, you can see our job is running currently. Now our job is successful. You can click on that and preview data, and I'll click on filtered dataset. Now there is only 6 columns present. The 26 reduced to 6 columns, and 1 is the label column, price, and other 5 are the features. So it has selected the most relevant features. this is the filtered data and it has done feature selection as well. Now again, if we look the data, we can see there are not a number value and there are some, here you can see all these text values. We don't need those. We have to eliminate those. It will pollute our data set. So we don't need these kind of data. So that is what we are going to do next. Next is to clean the data. And I'll select the clean missing data module, drag and drop it into the canvas, and I'll connect the filter data to clean missing data. And I'll double click on clean missing data. It will ask which columns need to be cleaned. So I'll select all columns and save. Then again, it will ask about the cleaning mode. So you can select replace with mean, replace with median or anything. But I'm going to tell the model to remove the entire row. If some data is missing, then remove that entire row from the data set. That is how I'm going to clean my data. Then I'll configure and submit the job. So the pipeline job is running currently. So thing is, you can create the whole pipeline and submit it. But to make it simple, I'm executing it after adding each and every module so that we can clearly see what is happening with our data. So we can click on view details and our job is currently running. So it is successful and you can see it is completed and it took like 22 seconds. Now if I right click on that, you can see preview data and you can select cleaned data set. Now there won't be any non-number values in the data. So all those rows will be deleted. So now there is only 199 rows. Earlier there was 206. Now we deleted all the rows without proper data in it. So now we cleaned our data. Back to the authoring. Now what will be the next step? We have filtered the data, we have cleaned the data, and next is normalizing the data. So here in the data you can see this engine size is in hundreds but the curve weight is in thousands. So there is a huge difference in that numeric value. So we have to normalize the data and we don't need any feature getting more weightage while calculating the price. For that we need to normalize the data. That is what we are going to do next. For that, here you can select for normalized data and I'll be dragging and dropping this module here and I'll connect my clean data to normalized data. I can double click on this and the transformation method will go with the default one, z-score, then columns to transform. I have to select the columns to transform. So I'll select all columns, but we don't need to transform the label or the price. We don't want to normalize that. It should remain the same. All the other values we should normalize so that each of the features should get the same weightage. So I'll select all columns and also I'll select exclude column name and price. Exclude price. Everything else you have to normalize. I think this price you have to give the correct name of the column. I'll verify it here. Is it is price. Now include all columns in normalization excluding the price column. And I'll save it and I'll run the job. I'll configure and submit the job. Submit. Now the job is running on a compute instance and you can view details here. So it's currently running. So now that job is done. And if you right click and click on preview data, you can see the transformed data set. So now all the values are normalized. Now we have normalized the data. We have filtered the data. We have selected the features, cleaned the missing data, normalized the data. And the next step is to train our model. Before that, we have to split data. I'll select the split data module and I'll connect the transform data to split data. And it is split rows. So fraction of rows in the first output data set. Here I'll go with 80% for the training data and it will do a randomized split. And the next is to train the model. And I'll use this 80% data to train the model. And in train the model, I have to select the label column. So our label column is price. That is the one we want to predict. Then everything else, I'll go with default. The next is to select an algorithm for the model. So I'll go with regression because we are predicting a numeric value. So regression is the best, and I'll select the linear regression, which is one of the simplest form of regression. So that is the algorithm which I'm choosing. Then I'll connect that algorithm to the trained model module. We have connected linear regression to the untrained model and the 80% of our data set to the data set of the model. Now next step is to score the model. So it scores predictions for a trained classification or regression model. I'll drag it here, and for this we will use a trained model, and the data set will connect the remaining 20% of data for scoring. So the diagram looks complicated, but this is how it's done. We have connected the trained model and then the remaining 20% of our data set to score model module. Then finally we can evaluate our model, and I'll connect my scored model to evaluate model. So now we are all set with our pipeline. So this evaluate model will give our evaluation metrics. So I hope every connection is correct. If this connection is not correct, this arrow is not correct, it will mess up with our pipeline. So you should be very careful while connecting these arrows. Yeah, now we'll submit and run our pipeline. Now the pipeline is running. We'll go to view details. So each of these jobs are running. So once it's completed, we'll come back. So now our pipeline is completed and everything is successful. And if I right click on the score model and click on preview data, we can see the scored data set. So the model is already being trained, and then we are testing the model here with unseen data set with 20% of our remaining data. So here this is the label, price, the original price present in the data. Then these are the features, and if I scroll down, the last column is the scored labels or the values predicted by the model. So we can compare these values. So here the model predicted 19,698, and we can see what is the original value in the actual data. Okay, I have to scroll back. Go here. So it is 18,150. So there is not much difference between the actual value and the predicted value. Yeah, that's good. And here you can see 31,600. It is 25,361. So yeah, and here it is 6,918, and we can see the model prediction, which is 6,176. So it is pretty good. So you can compare the values predicted by the model along with the values in the actual data. So I feel like the model is kind of good. So yeah, that is the scored data set. And here you can see the evaluate model, the evaluation metrics. I can right click it and preview data, evaluation results. So again, we know that it is a regression model, and we already know what are the evaluation metrics for a regression model. Mean absolute error, root mean squared error, then relative absolute error, coefficient of determination. All these values you can see here. These are the evaluation metrics, the score data set and the evaluation metrics. So yeah, our machine learning pipeline job was successful, and we got a very decent model. So this is what is machine learning designer is all about. You will get a canvas, and there is an already pre-built modules present. You can select what a module you want. So the algorithm we applied is linear regression. Then we have our data. After that, we did some feature selection. We only selected 5 columns, 5 most relevant columns present in the data. After that, we cleaned missing data. There are different methods for cleaning the data. What we selected is to eliminate or delete the entire row if particular data is missing. So we cleaned the data, we normalized the data so that all the features will get equal weightage. After that, we split the data. So the module we selected is split data, and in split data we used 80% and 20%. 80% to train the model and 20% to evaluate the model. After that, we trained the model using linear regression algorithm, and using the remaining 20% of the unseen data set by the model, we evaluate the model and we saw the evaluation metrics. So these are the steps of the pipeline we followed. Again, you can use any data here. You can use your own data if you need. So this is what is Azure Machine Learning Designer. Now there is automated machine learning. So here you can see there is a high level automation. You don't need to drag and drop each and every module. Here you just provide the data, tell which type of machine learning technique you have to use, and then you can run the job. It is very highly automated. So here in the designer, we can see the pipeline we have created. Now the first step and the important step is to stop and delete our compute instance. So this will incur charge. So first I'll go and stop my instance and then delete it. I'll select that instance, click on stop. So don't forget to do this, otherwise it will keep on charging. So now it's stopping and I'll delete the compute. And also I'll delete all these jobs as well. Delete. And finally, I'm back to my Azure portal and I'll delete my Azure Machine Learning Workspace. Delete. Back to the slides. So we have seen a demo in Machine Learning Studio and we use the Machine Learning Designer to design a pipeline and execute the pipeline. So now next is the knowledge test. For a machine learning progress, how should you split data for training and evaluation? Use features for training and labels for evaluation. Randomly split the data into rows for training and rows for evaluation. Use labels for training and features for evaluation. Randomly split the data into columns for training and columns for evaluation. Now pause the video, figure out the correct answer and resume the video. So how do we split the data for training and evaluation? We have to randomly split the data in rows. That is how we split the data. And we cannot use labels for training and features for evaluation. That is not the correct way. Again, A is also incorrect and we don't want the columns. We need the rows. We have to split the data in rows and not in columns. So here the correct answer is option B. You are preparing to deploy an Azure machine learning model as a service for use by client applications. Which 3 steps should you complete in the correct order before deploying the model? Now we know the steps. First we have to prepare the data. After that we have to train the model. And after that we have to evaluate the model. So these are the 3 steps which we need. Prepare the data, train the model and evaluate the model. Now we have published an inference pipeline using Azure Machine Learning Designer to access the deployed web service from a client application. Which 2 parameters do you need? Again, one thing I forgot to mention while we were doing the demo is that we can publish our pipeline and we can use that endpoint to predict the price of our automobiles. So one thing is you can deploy our pipeline which we created and publish it. So once we publish that pipeline, which 2 parameters do we need to access that model? So what we need is the REST endpoint and the authentication key. Like all other Azure AI services, we connect to the machine learning deployed web service using the REST endpoint and the authentication key. Azure Machine Learning Designer lets you create machine learning models by select one correct answer by automatically performing the cleaning up of data. No, it doesn't automatically perform the cleaning of data. We have to select the module. We have to select the technique, which one we need to clean the data. Then it will clean the data. It doesn't automatically go and clean up the data for us. Adding and connecting modules on a visual canvas. Yes, it did that. We added and connected modules on a visual canvas. Then did it automatically select an algorithm for the model? No, it didn't automatically select. We selected an algorithm, linear regression, using a code first notebook experience. Again, that is an incorrect statement. Next question, select the correct features of automated machine learning in Azure. Ability to visually connect datasets and modules on an interactive canvas. That is the feature of Machine Learning Designer, not automated machine learning. Ability to include custom Python scripts in a training pipeline. Again, not a feature of automated machine learning. Implements machine learning solution without the need for programming experience. So that is what automated machine learning we can implement machine learning solution without the need for programming experience. Now, next question. You built a model pipeline using Azure Machine Learning Designer. What should you create before you can run the pipeline? A registered model, a compute resource, a Jupyter notebook. Again, very clear what we did first. We created a compute resource first. Next question. You need to create a training dataset and validation dataset from an existing dataset. Which module in the Azure Machine Learning Designer should you use? So, we should use the split data. Again, we saw this in our demo. Next question. Match the tool to the Azure Machine Learning task. Automated Machine Learning, Azure Portal, Machine Learning Designer. So in Azure Portal, we have to create a machine learning workspace. So for Azure Portal, it is to create machine learning workspace. Use a drag and drop interface used to train and deploy model. Again, we know that what is drag and drop thing. It is Azure Machine Learning Designer. So if this is 2, it is Azure Machine Learning Designer. And then use a wizard to select configuration for a machine learning run. If this is 3, this is related to automated machine learning. You're working in Azure Machine Learning Designer. Which 2 types of components can you drag and drop onto the design canvas to build a machine learning workflow? So, which are the 2 components? We can drag and drop the dataset and modules to the design canvas. Now, next question. What is a validation dataset? A validation dataset includes the set of input examples that will be used to train a model. So that is incorrect. Then it can be used to determine how well a model predicts a label. Then the third option is to verify that all the training data was used to train the model. So the correct option is option B. It can be used to determine how well a model predicts label. Then in this question, a pipeline is given and we have to fill these modules. Which are the components we should use here? So first, there is the raw data, and second, we know that we need to select the columns in dataset, or it is feature selection. So here it is number 2. Then there is clean missing data, and then next is to split the data. So it is number 5. And here we need to choose the algorithm to train the model. And here it is automobile price data, and we have to use the linear regression. So it is number 4. So here it is to select columns in the data set, then split data, and here it is the algorithm, which is linear regression. So that was our final question. Now, what did we learn from this video? We created a pipeline in Azure Machine Learning Studio and executed it. If you're following along with me in this demo, don't forget to delete the compute resource because it will incur charges to your Azure account. Now that's it. This is the final video of this series of course. We are all done with AI 900 certification preparation. We have discussed all the topics related to the exam. If you can get hands-on few practice questions, that would be great. Now we are all ready for the AI 900 certification. Now what is next? If you find machine learning and data science interesting, you can prepare for Azure Data Engineer Associate certification. If you find Azure AI services more interesting, you can prepare for AI-102 certification, that is Azure AI Engineer Associate certification. So what I did was I prepared for AI-102 certification and took that certification. I'll provide the link to the course which I attended for AI-102 certification in the description box below. It is a good one and I highly recommend that one. So that's it. All the best for your certification exam. If the series of videos helped you to pass the certification, please put a comment in the first video of this series so that I'll know about it and all others can be inspired. All the best for your exam. I'll see you soon. Thank you.